This is lesson 3.6, Factoring Trinomials, part 2. We call this lesson Split the Middle. That's the name of the method that we're going to be using. In this lesson, you are going to learn how to factor trinomials whose a is greater than 1. So that's our objective for this lesson. Before we begin, here's your do now. You have two example problems from the lesson 3.5. We have trinomials whose a is equal to 1. What was the method that you used? Go ahead and attempt these two problems. Push pause, and when you're ready to check, push play. Alright, ready to check? In example 1, it's a trinomial whose a is equal to 1, so we use our x factoring method. Recall from lesson 3.5, you write in the c term over the b term. So our c term is 24, our b term is positive 11. You look for the signs that you need of our two numbers that we're looking for. If the top number is positive, that means the signs are the same. To determine which signs you need, you look at your b value. So we need two positive numbers. You find the factors of c whose sum is b. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. If they were all positive, the only two numbers whose sum is 11 is 3 and 8. So then you write your answer in factored form. Two sets of parentheses. Whatever your variable is your first term in each binomial that you're trying to write. And then you write in your two other numbers with their signs, so positive 3 and positive 8. So the factored form of the polynomial x squared plus 11x plus 24 is the quantity x plus 3 times the quantity of x plus 8. Check your other problem. Again, we have a trinomial whose a is equal to 1, so we use our x factor method. Our top number is your c value. Your bottom number is your b value. You ask yourself, well, what's the signs of the two numbers I need? Well, my top number is negative, the bottom number is positive. When the top number is negative, we know the signs need to be opposite. The bottom number tells you which number is bigger. The bigger number is our positive number. Our smaller number should be negative. The factors of 48 are 1 and 48, 2 and 24, 3 and, if you have a calculator, it makes it easier, 16, 4 and 24, 5 doesn't work, 6 and 8. So if our smaller number, our smaller number should be negative, larger number should be positive. So the only two numbers whose sum is positive 13 is negative 3 and positive 16. Write your answer in factored form. We should have two binomials, negative 3 and positive 16. Okay, if you did not get those, you should go back to lesson 3.5 and review and practice some more on those. So in this lesson, we are going to be learning how to factor trinomials whose a is greater than 1. When you're factoring trinomials whose a is greater than 1, our answers should still have the same form that we had before, two sets of parentheses, and we're looking for binomials multiplied together. To start this off, you will write down your a and your c term, everything that you see, as your first term of your first binomial and your last term of your second binomial. Then what we're going to do is split the middle term with its factors, the factors of negative 11. So you will still use the x factor to find those two factors. And there's one extra step with your x factor. Before we had c over b. But now that because we have an a value, you need to multiply your a times your c to get your top number. So a times c is positive 18. Your b value still goes below. Our b value is negative 11. And what we're trying to do is find the factors of negative 11x, or the sum of them. Sorry. So just like before, you find the factors of your top number. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that's it. You do, like before, need to look at your sign patterns. We have a positive over a negative, so therefore they should be the same signs, and our b value determines what those are. So negative and a negative, negative and a negative, negative, negative. Which one of those pairs equal our b value? Well, 9 and 2 equal negative 11, or 2 and 9. These are actually negative 2x and negative 9x, because negative 2x plus negative 9x, when we add them together, equals our b value. So we're going to split those two terms up into our sets of parentheses. To determine which one goes where, ask yourself if they're divisible by one another. For example, this 6, can we divide it by 2 or can we divide it by 9? Well, I can divide it by 2. Now, if the number's bigger than their two numbers, then you ask in reverse. For example, can 9 be divided by 6? No, it can't. So I'm going to put my negative 2x inside the parentheses of my first binomial, and then negative 9x inside my other one. By the way, this is a positive 13, and I do need to write that sign when I bring it down. So I've split the middle term. Not done yet, because whenever you have a binomial, if there are any greatest common factors within a binomial, you do need to pull those out. That's always. No matter, even if we were in the previous lesson, we always got a binomial, they should never have any greatest common factors after we do this, but in this case we do, so we have to divide each binomial by their greatest common factors, the next step. So 6x squared and negative 2x has a greatest common factor of, not 3, but 2, because 6 and 2 can both be divided by 2, x. 2x and 2x. Just like before when we were finding the greatest common factor of a polynomial, and we're using that method to factor out, we write our 2x on the outside, and the answer to that division on the inside of parentheses. So 6x squared divided by 2x equals 3x. Minus 2x over 2x equals 1. Do this with the second binomial as well. The greatest common factor of negative 9x and positive 3 is negative. We always have a greatest common factor of a negative number whenever the first term is negative. Negative 3. Both of those can be divided by negative 3. So that negative 3 factors out. Make sure you put the sign here, even if it's positive. Please put the sign of your greatest common factor. So negative over negative is positive. 9x over 3 equals 3x. Positive 3 over negative 3 equals negative 1. When you get to this point here, what you actually have is a factored out one term, and this will be plus or minus a factor of another term. So we have kind of like a two-term expression. Do you see any common factors here? This right here. When you're splitting the middle, you will always have a greatest common factor that's a binomial. So you will factor that out. We'll write that greatest common factor of 3x minus 1, and you're dividing both of these terms by that greatest common factor. 3x minus 1, 3x minus 1, which will cancel those 3x minus 1's out, and what are you left with? The 2x minus 3. So when factoring a trinomial whose a is greater than 1, you will always have this situation. There'll be a binomial that's the same. You'll write first, and the greatest common factors that you pulled out, you will write second. You'll group them together. All right? This is probably the most complicated type of problem you will have. It really demonstrates your grit to work through them. You do need to practice these several times just to get all the steps down. So I'll demonstrate another one with you. Please write them down as I'm doing the steps. If I'm going too fast, just push pause so you can finish copying, and then push play so that we can continue. So let's do some more examples. Alright, we look at example 3. We have a trinomial, but a is bigger than 1, so we need to use our split the middle method. We write our two sets of parentheses. Kind of wrote that really big. Let me try rewriting that for you. I knew if I didn't rewrite that, I wouldn't have enough room to show you how to do the whole problem. Alright, so what we need to do is we copy down our a term, the whole thing, 5x squared. We copy down our c term, the whole thing plus its sign. And now we need to do the x factoring of our middle term to split it up. So x factor the middle term, you do need to multiply a times c. That's an often forgotten step, so please remember, multiply a times c is your top number. So 5 times 10 is 50. Our bottom number is still our b value, the 27. We need to figure out what signs we need of our numbers. We have a positive over a positive, so our two numbers, or two terms that we're looking for, are both going to be positive. The factors of 50 are 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 and 10, 6, 7, 8, 9, 10. Okay, that's it. That's all of them. If they're both positives, which one equals 27? Well, the 2 and 25 are 27. That's 2, whatever our variable x, and 25x. Those are our two terms, then when added together, equal 27x. Alright, we're going to split them up and put them with our 5x squared and our 10. To determine which one goes with which, inside which parenthesis, I ask myself which one are divisible of each other. For example, if I look at my 5 and my 2, can I take 5 and divide it by 2, or 2 divided by 5? No. But I can take 25 and divide it by 5, so I'm going to put my positive 25x with my 5x squared, and my 2x with the 10. The next step is I need to look at each binomial separately and pull out their greatest common factors. Erase this so I have some room here. So after I've split the middle, I'm now finding any common factors. I need to pull them out. 5x squared and 25x can both be divided by 5x. So I pull that out. 5x and I divide equals x plus 5. So those x's come out. Look at my second binomial. The greatest common factor here is 2. It's a positive 2. This is important. Remember that when you're pulling out your greatest common factor of the second binomial, that you also write its sign. You'll need that. 2x over 2 equals just 1x, or just x. Positive over positive is a positive. 10 over 2 is 5. Good place to check, because you should always, in parentheses, have the exact same two terms. Those are the greatest common factors now. I pull it out, and then I group my two greatest common factors in the previous step together. 5x plus 2. Last step, and this is important, is make sure, once again, I do not have any greatest common factors. X plus 5, no greatest common factors there. 5x plus 2, no greatest common factors there. So that's my final answer. So let's see, how many times did I find the greatest common factor? 1, 2 times. Greatest common factor. So what did I do? I split. Use my x factoring to find my two terms, then greatest common factor, greatest common factor. Let's try example 4. Alright, it has an a term, so I need to split. Bring down my whole a term. Bring down my entire c term with a sign. Use my x factoring to find the two terms when added together equal to the 3y. This one should be pretty easy. Do my x factoring. Multiply a times c. 10 times negative 4 is negative 40. Our b value is 3. Look for my signs. I have a negative, so my signs need to be opposite. My bottom number tells me which one's bigger, so my bigger number should be positive. Factors of 40 that equal 3. Just to help you out with a shortcut, if you're tired of writing all these factors, good thing to see here. If this bottom number is small, then I know my two factored numbers are going to be pretty close together, or two smaller numbers that are close together. So I know right off the bat 1 and 40, I have a big number and a small number. That doesn't have a great big difference to them. Probably will be all the way down the bottom of all my factors. I'll go ahead and write them all out here, but I do expect my last two factors to probably be the answer. 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, and that's my last pair of factors. And what had happened, look, if I have negative and positive, didn't I say that my last two factor pairs would probably be the answer? Had this bottom number been really big, then I expect one of my first factors to be the answer. So 5 and 8, and don't forget to put the variable on these, because they're the sum of these two needs to equal this value here, which, what happened here? Oh yeah, that's a negative, sorry. Yeah, that still equals the sum. My circle just got in the way there. Alright, so I need to write the terms inside the right parentheses. So I have a 10, check with my 5, are those divisible? Yes, they are. I can take 10 and divide it by 5. So I put my negative 5y inside my first set of parentheses, and my 8y inside the second set of parentheses. So what did I do next? Well, next I need to pull out the greatest common factors. Greatest common factors of 10y squared minus 5y. You could divide both of those by 5, and they both have a y term in them. So I'm going to pull those out. 5y, parentheses, divide. 10 over 5 is 2y. Negative over a positive equals a negative. 5y over 5y equals 1. Pull out my second greatest common factor, my second binomial. Both of those can be divided by 4. What did I tell you to do or remember to do when you pull out your second greatest common factor? Is to make sure you put the sign with it. So it's a positive 4. Divide. 8 over 4 equals 2y. Negative over a positive equals a negative. 4 over 4 is 1. Check. Yep, they have a greatest common factor now of 2y minus 1. So I write that 2y minus 1. Group my greatest common factors together. 5y plus 4. Double check that I do not have any more greatest common factors. 2y minus 1, nope. 2y plus 4, nope. I'm done. So I keep on saying in the last step to check to make sure there's no more greatest common factors. Example 5 is an example where you will have an additional greatest common factor. So let's try this one. It's a trinomial with an a, so this is an example of splitting the middle. Make our two sets of parentheses. Bring down your a term, 3x squared. Bring down your c term, plus 45. X factor to find your two middle ones that we need to split. So 3 times 45. Ooh, this number is going to get big. 45 times 3 equals 135. Look at your b value is 24, so we have a positive or a positive. That means that we're expecting two positive numbers. Our factor pairs of 135. Let's see, we know we have 1 and 135. 2 doesn't work, 3 does. 3 times, if you use your calculator, you'll get 45. 4, if you know your divisibility rule of 4, if you got a big number, look at the last two digits. I have a 35. Can you divide 35 by 4? No, you can't. That means 135 can't be divisible by 4. So it's a quick little trick to know whether or not a number is divisible by 4. How about 5? Well, it ends in 5, so we know it can be divided by 5. If you use your calculator, you should get 27. Check to see if 6 can. Here's another quick rule for 6. I see that it's divisible by 3, but it's not by 2. It's not in my list. In order for a number to be divisible by 6, or go into it evenly, it has to be divisible by both 2 and 3. So I'm not going to waste my time trying to find out if it's divisible or not. Check C is 7. I don't have any special rules for 7, sorry. 135 divided by 7 is 15. And if you go up, 8 doesn't work, 9 won't work. I don't think so. Say 8, 9. No, 9 should work. 9 and here's the divisibility rule for 9. If you add up the digits, this same rule applies for the rule of 3. Add up the digits. 1 plus 3 is 4, plus 5 is 9. If the sum of the digits is divisible by 9, then the big number can be. So 135 divided by 9 is, well, let's see, 9, 8. That doesn't look right. Nope. Hello. Can't subtract today, apparently. 13 minus 9 is 4. 45. So 5. Yep. So it goes in 15. Oops, what did I do wrong earlier? I already had 15. Oh, I know what I did. Sorry, I was looking at my work before. My 9 and my 7 and my 9 look the same. So no, 135 is not divisible by 7. It's divisible by 9, though. I tried working out the work before showing these to you today. Can't read my own handwriting, apparently. So we put in which one's equal to 24 if they're all positives? Well, 9 and 15 do. So 9, positive 15. We keep the variables with it, x and x. Now we need to determine which ones we need to pair. And I shouldn't have done all my work right below here because it makes it harder to find my greatest common factors later. I'm going to switch pen colors for you. So 9, is that divisible by 3, or can we take 45 divided by 9? Well, really we could do either or. So it doesn't matter which one you put where. I'm just going to, I know what 45 divided by 9 is, but I don't know just off the top of my head what 45 divided by 15 is. So I'm going to put the positive 15x with my 3 and my 9x with my 45. Alright, now I need to divide by the greatest common factors. I'm going to erase a little bit just so we have some room for me to show you how to do this. And I apologize if you were writing these all down on your paper, and if you don't want to erase it all, go ahead and push pause and recopy it maybe on a separate sheet of paper. There's not a lot of room to work on these. I should have done it off the side for you. Alright, so what was our next step? After we split the middle and we found which term went with each pair, then all the steps after this is greatest common factor, greatest common factor, greatest common factor. We're just pulling out the greatest common factor in every step. So 3x squared and 15x, the greatest common factor is 3x. Divide each one by 3x. You get 3x times 3's reduce, x squared over x is just x, plus these x's cancel, 15 over 3 is 5. 9x and 45 can both be divided by 9. A positive 9, so when I write positive 9 on the outside, I'm not going to forget to do that sign there. 9 over 9 is 1x. 45 over 9 is positive 5. I double check. Do I have the same thing here and here? Which becomes my next greatest common factor. I'm going to pull out x plus 5. And then I'm going to group my two greatest common factors together, 3x plus 9. Now here's my warning and caution. If you forgot to write your sign back here with that 9, then chances are you probably did this, or that you will do this. You'll have a 9 there. So always double check at this point that you have a binomial times a binomial. That means you need a sign, two terms. Remember, terms are separated by plus and minus signs, so you have to have a sign there. 3x with a 9 beside it is not two terms. Let me rewrite that for you. Sorry, just a second. Okay, so I have a binomial times a binomial. My warning before in the previous problems was to always check to make sure that you still have pulled out every greatest common factor that you possibly can. X plus 5. There are no greatest common factors in x plus 5. I can just write it down. But I do notice that 3x and 9, there is still a greatest common factor in there, a 3. If we divide both of those by 3, you'll get x plus 3. Now, before when we pulled our greatest common factors out, we always wrote them right there in front. That's fine, you can do that, but look at what we have going on here. I would not write your final answer in this form. Whenever you have a monomial that's a greatest common factor, so this answer actually does have 3 factors in it. We have 2 binomials and 1 monomial. Write your monomial in front. That's the standard form of this. So we would write 3 times x plus 5 times x plus 3. It does not matter which order you have your 2 binomials in, but standard form does state that we put our monomial in the front. Okay? So that's an example of when you'll need to find the greatest common factor out a third time. Let's take a look at example 6. There's an a and it's a trinomial, so we have to split the middle. Make 2 sets of parentheses. Bring down our a term. Bring down our c term with its sign. Use our x factor to find the other 2 terms that we need. Remember to multiply a times c. If there's an a, you have to multiply it. 16 times 3 is 48. Still copy down our b value. It's negative 25. We need the factor pairs of positive 48 that equal a sum of negative 25. Let's look and see what signs do we need. We have a positive over a negative. That means that we need same signs and they both have to be negatives. The factor pairs of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12. Can I do all these in my head all the time? No, I use a calculator. Feel free to use a calculator. 6 and 8. Those are all my factor pairs. If they're all negatives, I ask myself, which one of those pairs equals 25? Look down the list. Well, -1 and -48, that's -49, so it's not that one. -2 and -24, that would be -26, so that's not that one. I expect that it's going to be pretty close then. -3 and -16? No, that's -18. That doesn't work. -4 and -12, that equals -16. That's not working. Wow. -6 and -8, that doesn't work either. Alright. So yes, not all trinomials are factorable. If you go through all your factor pairs and none of them equal your b variable, then you cannot factor this. Not factorable. Now, just because it's not factorable does not mean that there's not a solution. Later on, we're going to learn how to solve these. We're not solving them right now, and this is important to know. You're going to have directions that say factor, and you're going to have directions that say solve. How do you know if I'm factoring or if I'm solving? Well, in this case, there's no equal sign. So when you have this and it says just to factor it, then you can just say not factorable. And that's as far as you can go. So only 2 more examples for you. As we do the last 2 examples, I want you to see if you can do these 2 on your, or do example 7 on your own, and push pause and play again just to check your work with mine. Alright, so if you've done number 7 on your own or attempted it, let's go through the steps and you can check your work with mine. We have an A value, so this is splitting the middle method. Make our 2 sets of parentheses. Bring down your A term. Bring down your C term. Find your X factors. Oops. Well, I'm not going to be picky here. Multiply A times C is a -72. Did you make sure that you multiplied 4 times -18? Yeah, don't forget those signs. If you didn't do that, go ahead and push pause, rework your problem to get the correct solution, because that will change everything on you. And then continue checking your work. Alright, our B value that you're trying to get is a -1. Again, did you make sure you used the right sign there? If you didn't, then fix it, push pause, fix your whole problem, and then push play again to continue checking your work. Alright, the factor pairs of 72. There's lots of them on this one. 1 and 72, 2 and 36, 3 and... Can't read my own handwriting here. I think I had to 24 there. 4 and 18, 6 and 12, 8 and 9. What signs do I need on these? Well, I have a negative on top. That means I need opposite signs. B determines which one's bigger. Bigger should be negative. So positives. If all these were positives, and these were all negatives, which pair equals -1? Well, the +8 and the -9. Write down my variable, P and P. Right, which one did you put where? Well, 8 can be divided by 4, but 9 cannot. So I'm going to write my 8p in my first binomial pair and my -9p in my second one. Now I just find greatest common factors. Greatest common factor here is 4p. 4p. So 4p times the quantity. 4 over 4 reduces. P squared over p is just 1p. Plus 8 over 4 is 2. My p's cancel out. In my second binomial, it has a leading negative coefficient, so I need to make sure my greatest common factor has a negative in it. Both of them can be divided by 9. So negative 9 times the quantity. 9 over 9 is 1. Just p then. Negative over a negative is a positive. Check your sign there. If you didn't write positive, then pause, fix your work, and then continue checking. 18 over 9 is 2. Alright, I have a common factor again of p plus 2. So write p plus 2 times the quantity. I group my greatest common factors together. 4p minus 9. Do one last check for any greatest common factors. P plus 2 does not have any more. 4p plus 9 does not have any more. There, you're done. Example 8. I'll split my middle. Six x squared, negative 9. Write my x factor. Whenever I have 3 terms, it's an x factor, like 3 judges on the show, x factor. Multiply a times c, I almost forgot to do that, is negative 54. B value is 25. Look at my signs. I have a negative over a positive. I need opposite signs, but my bigger number needs to be positive. Factor pairs of 54 are 1 and 54. 2 and, let's see, 25, 26, 27. 3 and 54 divided by 3. 18. 4 doesn't work. 5 doesn't work. 6 and 9. 7 doesn't work. And 8 doesn't work. And there I'm down back to 9 again. So those are all the factor pairs. If my smaller number's negative and my larger number's positive, which one equals 25? Not that one. Positive. These two do, don't they? 2 and 27. So I have a negative 2x and a positive 27x. Split them up, decide which one goes with which one. Let's see, I could take 6 and divide it by 2. I can't take 27 and divide it by 6 though, so I'm going to put my negative 2x in my first set here and the 27x in my second. Now I'm trying to find greatest common factors. These can both be divided by 2x. So 2x times 3x minus 1. These two can both be divided by 9, or no, 3, sorry. Divide by 3, divide by 3. So a positive 3, 27 divided by 3. No, that could be, sorry, you're right, or I was right earlier, is 9. I almost didn't pick the greatest common factor there. Both can be divided by 9. So positive 9 is 3x minus 1. And I would have noticed that I did something wrong, because if I would have continued to divide by that 3 and didn't use the greatest common factors, those two binomials would not have matched. So I factor out the greatest common factors here of the 3x minus 1, and I group my two greatest common factors in the previous step together. Oops, I wrote 3. 9. Look for any more greatest common factors. Nope, don't see any. There's my final answer. Okay, good luck with this lesson. Work hard in there. Remember grit. I know there's lots of steps. Just split the middle, X factor, greatest common factor, until you don't have any more. Good luck on these. Go ahead and do the independent practice and turn that in for a grade.